Eigenvalues and Eigenvectors. This lecture is a very important lecture because these two concepts, the concept of eigenvalues and eigenvectors, this you will see everywhere in linear algebra and also in machine learning, because in machine learning you use a lot of linear algebra concepts. So every here and there, when we once we go in a bit more deeper into machine learning or a bit more deeper into any of the linear algebra concepts, you'll see that eigenvalues and eigenvectors, they play an important role. And the thing is, when we explain those concepts, if you don't already have a clear logical idea of what is eigenvalue and what is eigenvector, what does it represent, it will be difficult for you to grasp many concepts. You'll feel like that concept is also not clear to you. So make sure that eigenvalues and eigenvectors, this is clear in your mind. See, it's not just about deriving the values for eigenvalues and deriving what is an eigenvector. It's important to understand, actually more important to understand, that what is the significance of this eigenvector? What is the significance of eigenvalue? What does it represent? Deriving it, finding the solution, that's the second thing. You should know that, but that's a secondary thing. First, most important thing is, once someone tells you that this particular matrix has this eigenvector and this eigenvalue, you should be able to have a logical understanding of what this is. What does this vector represent? As far as this particular matrix is concerned, what is the relation for this vector with the matrix? Okay. So let us start. Coming to eigenvectors, take any square matrix. Let us say I am taking some square matrix A. In that case, eigenvector is a non-zero vector V that only changes by a scalar factor when the linear transformation represented by A is applied to it. That is, let us say in the Cartesian space, you have some vector V. Let me call this V. When you apply some matrix to this vector, that is, you multiply this vector with a matrix. Let us say my matrix is A. If I multiply A with V, what does it happen? Whenever you multiply any vector with a matrix, it will apply some transformation on this vector. That is, it will change in direction, it will change in size and so on. So this vector, it will become something like this. That is, this vector, which was V, will now maybe it will become this. That is, it got enlarged and it also changed in direction. And maybe you applied another matrix. You applied some other matrix B on V. When you apply that, maybe V will become this. That is, it shrinked and also it changed direction. So this is how different matrix operations will affect a vector. Whenever you multiply any vector with a matrix, that vector will change in direction, it will change in size. So this is what happens by default. What is the speciality of an eigenvector? If it is an eigenvector, this vector will only change by a scalar value when you apply the corresponding matrix. That is, it won't have any other transformation. So if V is an eigenvector of the matrix A, then if you apply this transformation A into V, this V may become something like this or something like this. That is, it may increase in size or maybe it will shrink in size. It will become only up to here. Okay, it will become this. But this won't change in direction. This won't happen. That is, it can't change in direction if it is an eigenvector. So whenever you are given a square matrix A, the speciality of eigenvector is that whatever matrix operation you do on this V, that is with the matrix A, if you do a matrix operation on this vector V, if you multiply this V with A, it won't change its direction. It would keep its direction and it would shrink or enlarge. This is what will happen. This is what an eigenvector is. What is an eigenvalue? The amount by which this eigenvector enlarges or shrinks, that is represented by eigenvalue. You normally call eigenvalue as lambda. So what does this lambda eigenvalue represent? If the value of lambda is 2, that means your vector doubled in size. When you multiplied your vector with the matrix A, the vector will double in size. That is, initially it was this. When you multiplied with A, what happened to V? It became doubled. That is what means if your eigenvalue is 2. So eigenvector is the corresponding vector for a square matrix which will not change in direction if you multiply with that matrix. That is, when you do the matrix operation, the vector will keep its direction. And eigenvalue tells you by what extent it will increase or shrink. Okay, this is what eigenvalue is. Now let us see how do you find out the values of eigenvalue and eigenvector. So once you have the logical understanding clear, conceptual understanding clear, it's okay to go to the next step, that is how to find eigenvalue, how to find eigenvector. Let us see. In order to find the eigenvalues and eigenvector, first thing is characteristic equation. You want to find the characteristic equation of that matrix. If A is your matrix, then what is the characteristic equation? Find this out. Determinant of A minus lambda I is equal to 0. If you solve this, you will get an equation which is in the polynomial lambda. Okay, this will be a polynomial equation which will be on lambda. And this lambda is this polynomial which is in lambda, that is called the characteristic polynomial. So you will get some polynomial like 5 lambda square plus 3 lambda plus 1 equal to 0. Some sort of an equation like this you will get if you solve. And that equation will be called as the characteristic polynomial. And from this characteristic polynomial, if you find the roots of this characteristic polynomial, you will get eigenvalues and values. And when you find this eigenvalues and then using the eigenvalue, you can find the eigenvector. How do you find eigenvector? You solve this A minus lambda I into vector V is equal to 0. Whichever vector satisfies this particular property, those vectors are called eigenvectors. So corresponding to any eigenvalue, you will be able to find the eigenvectors. So this is how it is to be solved. We'll do one thing. We'll solve one random example so that you get the idea clear. It gets clarified in your mind how you can find eigenvalues and eigenvectors. Okay. So geometric interpretation is clear, right? What is an eigenvector? A direction in the vector space. A direction in the vector space that is invariant under the transformation A. Okay. That is, when A is applied to this eigenvector, it does not change in size, in direction. It only stretches or shrinks. That is what you call as an eigenvector. And what is the eigenvalue? It is a factor by which the eigenvector is scaled during the transformation. Now let us see how to find the eigenvector and eigenvalue. That is, we'll see with an example so that you understand clearly how can you find the eigenvectors. Let us take an example, a square matrix. Let A be 4, 1, 2, 3. Let us say this is a matrix. If this is the matrix, how do you find the eigenvalue? In order to find the eigenvalue, you want to do determinant of A minus lambda I equal to 0, right? Determinant of A minus lambda I is equal to 0. This is what you want to do in order to find the eigenvalue. What is lambda here? Lambda is the eigenvalue you are searching for. What is I? I is the identity matrix which is having the same dimension as that of A. That is, here in this particular case, I will be identity matrix with the same dimension of A. What is the dimension of A here? It is 2 cross 2 by 2 matrix. So it should be 1, 0, 0, 1. This will be your I in this particular case. So what will be your A minus lambda I? That will be 4, 1, 2, 3. This is your A. 3 minus. What will you get if you multiply lambda with this? All the ones will become lambda. Zeros will remain as it is. So this will be lambda 0, 0, lambda. This will be your A minus lambda I. So this matrix will be 4 minus lambda 0. Sorry, this is 1. 2 minus 0 is 2. 3 minus lambda is 3 minus lambda. So your matrix A minus lambda I will become 4 minus lambda, 1, 2, 3 minus lambda. What is the next step? You want to do determinant of this matrix. You got the matrix A minus lambda I. Now you want to take determinant of this matrix and equate to 0. How do you find the determinant? When you take the determinant of it, it becomes 4 minus lambda into 3 minus lambda minus 2 into 1, right? So in minus 2 into 1. I'm erasing this off. This is equal to 0. So you are equating the determinant of a minus lambda I to 0. This is how you find eigenvalue. What will you get here? 4 into 3 is 12 minus 4 lambda minus 3 lambda plus lambda square plus 2 is equal to 0. So this will be lambda square minus 7 lambda plus 10 is equal to 0. Correct? So this is your characteristic polynomial. Your characteristic polynomial is lambda square minus 7 lambda plus 10 is equal to 0. How do you find the eigenvalues? Eigenvalues are the roots of this characteristic polynomial. How do you find the roots of the characteristic polynomial? I'll keep a the 4, 1, 2, 3. This is where you started from. Let us find the roots of this equation. Lambda square minus 7 lambda plus 10 is equal to 0. How do you find the roots? Lambda is equal to 7 plus or minus root of, what is 7 square? 49 minus 4 times a into c, which will be 4 times 1 into 10. That will be 40. Okay. Minus 40 divided by what is 2a. So it will be 2. So this I am not explaining because it is very simple. So 7 plus or minus, what is root of 9? 3 divided by 2. This is where you reach. That is equal to 5 and 2. These are the two eigenvalues. So now you understood that the eigenvalues corresponding to this particular matrix are 5 and 2. That is, there are two options. So corresponding to these eigenvalues, you will be able to find two different eigenvectors. And what will be the speciality of those vectors? The eigenvector that you find corresponding to the eigenvalue of 5, that will become 5 times when you apply this matrix without changing the direction. Similarly, if you take the eigenvector which is corresponding to the eigenvalue 2, that vector will become 2 times its initial size if you apply the transformation A. That is what that eigenvector is. Let us just find the eigenvector as well in order to have a completion on this so that you will also understand what exactly it is. So the eigenvalues are 5 and 2. I'll write it here. 5 and 2. These are the eigenvalues. Let us first find the eigenvector that is corresponding to 5. Our first eigenvalue is 5, and let us see what is the eigenvector corresponding to that. What do you have to do? You have to do a minus lambda I into v is equal to 0. So this is the vector, and whichever vector satisfies this, that will be the eigenvector corresponding to the eigenvalue 5. So let us find this out. A minus lambda I. So that will be 4, 1, 2, 3. This is your A minus what is lambda I? Lambda I is the identity vector. So this will be, lambda is 5 here. So now you know the value of lambda. You are using the value 5 because you're finding the eigenvector corresponding to the eigenvalue 5. So lambda I will be 5005. Okay. This is your lambda I. This into your vector v should give you 0. So what will this become? 4 minus 5 is minus 1. 1 minus 0 is 1. 2 minus 0 is 2. And 3 minus 5 is minus 2, right? So this into v is equal to 0. This is where you reached. So now if you apply this v inside, you will get, one is minus v. Let us say you have two vectors here, minus v1. So this vector v can be decomposed as, let's say, v1, v2. Okay, this v. So if you multiply it, you will do like this into v1, v2. This is equal to 0. If you solve for this, what will you get? You will get minus v1 plus v2 equal to 0. So that means v1 is equal to v2. When will both are equal means you can consider the eigenvector is 1, 1. Okay, v1 equal to v2 is what you got. v1, v2 is the eigenvector. So it can be 1, 1. So here direction is what matters rather than the size. eigenvector should give you the direction and the size will be provided by lambda. So v1 equal to v2 will provide you 1 1. So you understood that the eigenvector corresponding to the eigenvalue 5 is 1 1. So your first eigenvector is 1 1. Let us find the second eigenvector, that is corresponding to the eigenvalue 2. How do you find that? You do a minus lambda I. You want to do a minus lambda I into your vector should be 0. This is what it should satisfy. A is 4, 1, 2, 3 minus what is lambda? Lambda is 2. So lambda I will be 2, 0, 0, 2. This into your vector v should be 0. What is 4 minus 2 is 2, 1 minus 0 is 1, 2 minus 0 is 2 and 3 minus 2 is 1. So you got 2, 1, 2, 1 into your vector v is decomposed into v1, v2. This is equal to 0, which means you got 2v1 plus v2 equal to 0. So this means the eigenvector will be 1 and minus 2. So 1 minus 2 is the eigenvector corresponding to value of lambda 2. So the other eigenvector is 1 minus 2. So you got 2 eigenvectors and 2 eigenvalues, which means here are the eigenvectors. Corresponding to the eigenvalue 5, you have an eigenvector 1 1, and corresponding to the eigenvalue 2, you have an eigenvector 1 minus 2, which means to this vector 1 1, if you apply the matrix 4 1 2 3, it will become 5x, and if you apply to this vector 1 minus 2, the same matrix 4 1 2 3, it will become 2x. This is what it means. So here one thing is you should clearly understand what is eigenvector, what is eigenvalue, what is the concept, and how to derive the eigenvalues, and from that the corresponding